Alright, hello everyone. So you're welcome to the next section of these exercises. Okay, so as you join, please like the video, give a thumbs up to it. Okay, alright. So now in the last session we ended at number 10 of the exercises. And we're able to see, okay, 1 to 9. Of course, 1 to 9 had some subsections. Okay, so here I asked you to do this. Okay, so probably I'm going to do it here just to ensure that you did the right thing. Okay, so log 225. 225 is the same thing as 15 squared. So all over log 15. So why did I take it to 15 squared? Because I have log 15 below. Okay, so I would then try to simplify by the rule of log, which says that if I have log of x to the power of n, that is the same thing as log of x, no matter what the base is. Okay, so that's going to give me the log of 15 all over log of 15, and that's equal to the log of x. So this will take away this. Okay, so we can finish up here. So note that you now have 2 is equal to, or let me write it the other way around. You now have that log x is equal to 2. Okay, so you notice that there was a place I mentioned the concept of common logarithms. Okay, so, and I said that if a logarithm does not have a base, then it's a common logarithm. That means its base is 2. Okay, so from here we can now get the value of our x, which is what they asked us to do. And how do you do that? This is going to give you that x alone is equal to 10 to the power of 2. How? Because by the definition of logarithm, if you have log x base a equal to n, it simply means that x is equal to a to the power of n. So the number of a log is equal to the base of that log raised to the power of the value of the log. Therefore, our x is equal to 100. Okay, and that is the solution, and I hope you got that in your exercise. Okay, so we move now. Let's see how far we can go in this section. Okay, number 11 says that you are given that 128 plus 80 excuse me. Okay, sorry about that. So we are told that the square root of 128 plus the root of 18 minus the root of k is equal to 7 root 2, and we are to find the value of k. So what do you do now? So you can clearly see that all you need to do here is to try to simplify, to look for a way to simplify what you have, and the best thing is to actually bring this one over to this side and take root k to this side. But before we even go there, we know that 128 is the same as 64 times 2. Why did I break it this way? Because 64 is a perfect square root. Then I'll come here. This is the same thing as 9 times 2, because 9 is perfect. So I'll bring over this one, and that will give me minus 7 root 2 is equal to this one coming over here will become positive root k. Okay, so from here I can easily simplify. Then if I take the root of 64, I'll get 8. That 8 comes out of the square root. Here I'll get 3. It comes out of the square root, and you have root 7 root 2. Okay, so and immediately we can now do sum and subtraction. 8 plus 3 is 11, minus 7 is 4 root 2, equal to the root of k. Okay, so and to now get our root k, our k, all we need to do is make this thing to become a single root by bringing in the 4 into the square root. And when you do that, when 4 comes into square root, it becomes the square of 4, which is 16, and it will multiply the already existing number there, and that will be equal to k, root k. Therefore, our k alone is the value of what is under the square root, which is 32. And that is the answer for number 11. Okay, so quickly we move over to the next. Okay, so which is number 12. 12 says that we should simplify, is another simplification, the root of 80 plus the root of 20 plus minus the root of 45. Okay, so when it comes to simplification, you are only looking for a way to make all the square roots to be similar so that you can add or subtract. Remember, you can only add or subtract similar surds. Okay, so I'll try to check what are the numbers, the products that can give me this. So 16 and 5 can do it. Remember to always do it in such a way that 1 will be a perfect square. Okay, then plus here also 4 and 20, they are good to go, minus the root of here 9 and 5. Did I say 4 and 20? I meant 4 and 5, not 4 and 20. What we have there is root 20. Okay, so 4 and 5 can go. So, and you are done. The root of 16 is 4, so 5 still remains in the root. Root of 4 is 2, 5 still remains in the root. And root of 9 is 3, 5 there is still in the root. So we have 4 plus 2 is 6, minus 3 is 3, then root 5 finally, and that is the solution. So let's see if question 8 will enter here. Okay, so 13. Okay, so let's call the 13 another simplification. So now we have moved from logarithm to surds. So you are asked to simplify something of this nature. 7 root over root 2, and then root 32 plus 6 all over the root of 2. Okay, and that is going to give us, so there are a number of things you can do here. One of it is to open up these brackets and then see what it will give. So if we do that, we are going to have, this will multiply this to give you 7 root 32 all over root 2, plus here you will have 7 times 7 is 42, and root 2 times root 2 is root 4, which is 2. Okay, and so here the same thing will happen. You are going to have 7 into, here, division can split over, root can split over division. So this will be the root of 32 over 2, which is root 16. And root 16 is 4. So you have 7 times 4 plus 42 over 2 is 21. And that will give you 28 plus 21, which is equal to 49 as the solution. So 49 is the solution for problem 13. Okay, so let's quickly look at problem 14 now. So 14, maybe we should come down a little bit. Let's see how fast here can help us. Okay, so exercise 14. It looks a little bit demanding. Let's see. You have if the square root of 3x squared minus 7x minus 30 plus the square root of 2x squared minus 7x minus 5, okay, is equal to x plus 5. So we are to find the value of x. Wow, so this is another amazing question or problem to handle. Okay, so whenever you are given two radical terms in an equation, it's always good to move one of the radical to the other side. Let the two radicals not be on one side of the equation. It will actually be easier to handle that way. So in doing that, I'm going to have that the square root of 3x squared minus 7x minus 30 is equal to, so I already have x plus 5 on the right, so I'm only going to bring this over, and that will be minus the root of 2x squared minus 7x minus 5. What a beautiful equation. Okay, so at this time we can now try. Remember that whenever you have radical equations, your major concern is how to remove the radicals, and when you remove the radicals, you can now solve the equation to get the to get the variables you're looking for. Okay, so here we'll try to remove the radicals on the left by taking the square of both sides. So if we take the square of both sides here, permit me to do it here. So this square will cancel square root. You have 3x squared minus 7x minus 30. So our left hand side is clear. So we need to see if we can clear the right hand side. Now on the right hand side there are two terms here. So we are assuming that this one is 1 and this is another. And we want to multiply out the two. Remember, if you have a minus b into a minus b, what you will get is that a will multiply a, which is a squared. And you can also do b multiply b, or you just do it, a should multiply a and also multiply b. So you have minus ab, and your b will do the same thing because you are done with a. So you have minus ab, and then minus b times minus b is plus b squared. Okay, so this is going to give you a squared minus 2ab plus b squared. I'm going to use that here now. So my a now is x plus 5. So I will have x plus 5 all squared minus 2 times a, which is x plus 5, then times the whole of this, which is in place of my b. Okay, and that is the root of 2x minus 7x minus 5. Okay, then I have gotten 2ab, so it's remaining b squared. So for b squared, that will be the square of this, and of course it is negative, so even if you square it, it will still be positive, and the square will cancel the square root, and so you will just have you will just have 2x squared minus 7x minus 5. Okay, so that's beautiful enough, right? So what do you do from here moving forward? So you try to first of all open up every bracket that you have that can be opened. So I'll bring down this one. If you open this bracket, you're going to have of course it's going to be x times x, which is x squared, x times 5, which is 5x, and then 5 times x, which is another 5x. So here is going to be 10x, then 5 times 5 will now be 25. Okay, so I just jumped only one line there. Okay, so and then that is going to be plus this one, so plus 2x squared minus 7x minus 5, while this is going to be minus 2 into x plus 5. The whole of them, they are multiplying the square root, so you don't make any mistake to remove them until you can use something like division. Okay, so let me leave this the left the way it is. Let me work on the right first. So here now, collect like terms. X squared will add this, and that will be 3x squared. Now 10x minus 7x will give me 3x, and 25 minus 5 will give me plus 20. If you notice, I didn't do anything here because this is actually attached to this with multiplication. So I'll just bring it down. It will keep being there until I'm able to divide. Okay, so this is going to give me 2x squared minus 7x minus 5. Beautiful. Oh God. Okay, so let's see if we can carry this over to another page. So let me write this: 3x squared minus 7x minus 30. Let's try it. Okay, Oh, no. Okay. Let's just, since the other one has been covered, okay, so let's just pick this to a new page. Let's see if it will add. Okay, it does. Okay, it does. Okay, let's drag it up a little. All right, so that means we are going to add what we added earlier on. So this is adding to this, which is 3x squared, and this 10 minus 7 is plus 3x, and then 25 minus 5 is plus 20. Then we'll bring down the other one like we did. So this will be the square root of 2x squared minus 7x minus 5. Remember that this thing is 5. Okay, so remember that this guy will still come down. So if we bring it down, something is going to happen there. You are going to see a beautiful math there. 3x squared will take away 3x squared, and then you can take the rest to the other side. So if 3x here is going to be minus 7x, this one coming will be minus 3x. Here you already have minus 30, this one coming will be minus 20, and here we'll have minus 2 into x plus 5. Okay, and that's the square root of 2x squared minus 7x minus 5. Remember that what would have been easier for us is to bring this guy into the square root. But if we do it, that means squaring it. That's going to give us a lot of work to do. So we'll still maintain this and see what is going to give us. Minus 7 minus 3 will be minus 10x. Minus 30 minus 20 will be minus 50. And that is equal to minus 2 into x plus 5. Okay. So here you have 2x squared minus 7x minus 5. Beautiful. So what do? There are common terms on the left hand side. Minus 10 can go in. So if I bring out minus 10, I will have only x left here. And minus 10 divide this, I'll have plus 5. Wow, this is amazing. Oh, this is giving us something nice here. Very, very nice. Because we needed a way to clear the coefficient of this square root on the right hand side. You know, either bringing it into the square root, which will give us a quartic equation, an equation of degree 4. And that will be a little bit more tedious for us. So, but what we did now has just helped us do that. So it will immediately clear away this. You know, x plus 5 will clear. And then minus will clear minus. Okay, 5 here, 2 will clear here, and 2 here will be 5. Wow. And you are almost done. So only 5 is left on the left hand side, and on the right hand side you have only the square root, which is amazing. That's exactly what we wanted. And why is it so? Because that can help us clear the square root to the left hand side, and if it becomes square, and the square of 5 is 25, which is equal to 2x squared minus 5x minus 5. And immediately we will form the quadratic equation by taking 25 to this side, which will give us 2x squared minus 7x. 25 coming over here will become minus 25. And so minus 5 minus 25 will give us minus 30, all equal to 0. And this is beautiful. So immediately you have gotten a quadratic equation which we can solve to get us a solution. And then we will try to see if factorization can do it. Okay, so can factorization do it? Are there two numbers that you will multiply to get 30, and when you add, you will get minus 7? Do we have such? Sorry, it's not 30. You know your A will multiply your C. And if 2 multiplies minus 30, you get minus 60. Thank you. Okay, so you are going to do two numbers that when you multiply, you get minus 60. And when you add, you get minus 7. And that's easy to see, which are 12 and 5. So your 12 will be negative so that you can get minus 7. Alright? So that's going to be, you open, Okay, in this case, the coefficient of x squared is not 1. We can actually open brackets if we want, but should I teach you that here? Okay, yeah, we can learn it here. You can still open your bracket and put it this way, then put another x this way equal to 0. So you now put those two things that we got, which is minus 12 and plus 5. Okay, so now the reason we usually would leave it like this in the other examples we did is because the coefficient of x squared is 1. So even if it does this thing we want to do now, it will still remain the same. So here, since it is not 1, we are not going to leave it that way. See what we will do? You will use that coefficient to divide these constant terms. So here you are going to have 12 over 2, which is 6. And here you will have 5 over 2, which you can leave that way, equal to 0. Finally, your x is equal to 6 or minus 5 all over 2. This is so amazing. I love this particular example. Okay, so and that is the end of surd exercises here. So the next one now is on polynomials. Okay, so the next example or problem is on polynomials, and that is problem 15. I think our last problem is 14. Am I right? Let's check. Okay, yes, it's 14. So we are going to the number 15 now. Okay, so 15 says write the sum and product of the roots of the following. Okay, so we want to write the sum and the product of the roots of a quadratic equation. So the general form of a quadratic equation is x squared plus bx plus c equal to 0. And we said that if you use completing the square method, you are going to get to a point where you will get x squared minus minus alpha plus beta x, then plus c is equal to, not c, plus alpha beta is equal to 0. And if you compare these two, we were able to now get a relationship that says 1, the sum of the roots of an equation is equal to minus b all over a of that equation. And then we also saw number 2, that the product of the roots of a given equation is equal to c all over a. Okay, and this is what is going to help us to answer this question. So for a, we are given to find the sum and product of the roots of 3x squared minus 2x minus 7 equal to 0. Okay, so if we begin the first part, the sum, which is equal to alpha plus beta now, will be equal to minus b. Please, what did I write? Minus 2. Okay, so please notice that it's important that you write out what you have. Our a is 3, our b is minus 2, and our c is minus 7. All right, so let's go. So you are going to have minus times minus, and that is all over. Okay, that's our minus b. That's all over a, which is 3. So that's going to give us 2 all over 3 as the solution. And then, okay, the second one. Okay, they said sum and product. Okay, we can actually do product here. So the product will be alpha beta, which is equal to c over a. And our c is minus 7. Our a is 2. So you can actually stop there as, our a is 3, not 2. Our a is 3, okay? So, and you can actually stop here. Okay, for the second one, we are giving 2x into x minus 1, and we say is equal to 5. So whenever you are given such you need to put it in the standard form, which is ax squared plus bx plus c. So to do that, here we open the bracket. 2x times x is 2x squared. 2x times minus 1 is minus 2x. And 5 coming over there will be minus 5 equal to 0. So from here we can easily now do the solution for for sum of roots and the product of roots. So what is the sum of roots here? Is still the formula minus b over a. And what is our b? Our b is minus 2 all over our a is 2 also. And so you will get 2 over 2, which is equal to 1. And finally, you have the product of your roots, which is c over a, will be equal to negative 5 all over 2. And that will give us minus 1 whole number 1 all over 2 as the solution. And that is for the II of number 15. Okay, and there is a triple I which I would like us to see, and then we will progress from there. There's a triple I. Okay, and this triple I feel I'm going to leave it for you as an exercise. So there you are asked to find the sum of the roots of this equation and the product. So 1 over 2x plus 1 over y plus 1, and finally equal to 1 over 3. Okay, so I think I'm going to leave this as exercise, and I'm also going to call off the class now. Okay, so we may continue some other time in the morning or later on this evening. Okay, so ladies and gentlemen, because of our time, it's already past midnight, so let's find some rest for this night, and we'll continue from here in our next class, either early this morning or tomorrow or today's evening. All right, good night everyone. Bye.